Hello, folks, to all the timely attendees of this Turing Institute and Genomic AI Network collaboration on Genomic AI. This is the second of our workshop Lunch and Learn series on implementation of AI in genomics. And if you see the slide that's up right now, this is an upcoming in real life event, a masterclass in implementing AI in genomics happening in June. If you scan now, you'll be some of the first person on this list. This is for the specialized NHS workforce in genomic medicine, laboratory and clinical, an in-person practical workshop with two streams, laboratory stream and clinical stream, focusing on tools such as, for the laboratory side, AI-powered biocuration, as well as AI-powered variant interpretation tools, including practical and interactive demonstrations. And on the clinical side will be ambient scribes, such as things you may have heard of like Heidi and Tortoise, as well as AI-powered dysmorphology tools like Emedgene or GestaltGAN, again with practical demonstrations from often the creators or early adopters of such tools. I'll leave that on for 30 seconds more for you to scan and get your registrations. Do be aware that this is an NHS only invitation currently due to the stipulations of the Genomic AI Network, so the highly specialized NHS workforce in genomic medicine, both on laboratory and clinical side. Whilst you're doing that, it's a pleasure to introduce our key opinion leader and speaker today, who is Miranda Durkie. We're very grateful to have Miranda here, who's been exceptionally generous with her time. She's the rare disease lead and consultant clinical scientist for Northeast and Yorkshire GLH, leading a really important piece of work in reviewing the characteristics of the different AI-powered variant interpretation tools, as well as the practicalities on their implementation, including the working group on a particular tool called Emedgene from Illumina. And with that, I'll pass over to you, Miranda. Thank you very much.
Thank you, Alex. Let me just share my slides. Everyone see that okay? Thumbs up. Brilliant. Thanks, Alex. So yes, thank you very much to the Genomic AI Network for having me to speak today. So I'm going to focus on kind of AI-driven decision support software that's in use in the NHS. And my talk's going to be kind of in two different parts, so two different hats on. So one hat is the rare disease lead scientist for Northeast Yorkshire GLH, and talking about some work we've done to validate and implement one of the DSS into NHS diagnostic practice. And that's in Sheffield in the Northeast Yorkshire. And then the second part is with my Genomic Rare and Inherited Disease Network of Excellence hat on. So this is a different network of excellence to the Genomic AI Network. And in that, I'm leading a project looking at evaluation of multiple DSS tools for exome and genome sequencing. So I thought I would start with kind of one slide, a bit of an overview about what does a DSS do in terms of if there's anyone here that's not familiar with them. And I kind of put it in grey because I get asked this question a lot. It's like, is it really AI? I would say I am definitely not an AI expert. I'm coming from a point of view of a clinical scientist who wants to use AI to make our kind of lives a bit easier. In terms of that question, I would say it's definitely not kind of artificial intelligence. Most of the tools I'm looking at are using machine learning, and it's based on very much kind of rule-based filtering. I think it's really important to state that I haven't come across any tools, or certainly so far, that use generative AI. I think this is really important. Probably as shown by this diagram, I was trying to kind of make a nice diagram to demonstrate what a DSS does, kind of having all the data from different sources rather than using text. But as you can see, there are a few glitches here. And this was actually the best image I came up with. And I'm bit kind of kicking myself because one of the others, I think I was putting in prompts such as an individual with a genetic disorder, yeah, one of them then came up with an image with a person with 4 arms, which is not a genetic disorder I have ever come across. But yeah, I think this is some of the kind of AI usage that kind of worries people a bit more, and I think it's important thinking about things like governance. So, sorry, bit of an aside, but yes, in general, a DSS, you tend to have kind of 2 options. You can either do secondary analysis or tertiary analysis. Majority do both, but some are a bit more limited to the tertiary. So the secondary analysis means that you take your kind of raw sequence data files and you are running it through your bioinformatics pipeline. So that is then mapping all your reads to your reference genome, doing all the quality scores, getting rid of artifacts, and generating a list of your variants. And that format that you have get your variants produced is called a VCF. Others only do the tertiary analysis, where you've already had your bioinformatics pipeline run and you put in that VCF file into the software, and it's then going to exclude and annotate the variants for you. So what's really good about these softwares, it does things a lot quicker than humans can do, and integrates multiple data sources. This includes data from the literature, databases such as Nomad and ClinVar, some do HGMD, includes the phenotype of your patient, usually via HPO terms, obviously the pedigree, and it does a lot of annotation of the variants to save you time. Most use some form of auto classification using the ACMG criteria, and then kind of excluding the variants that they think are low likelihood of being kind of causative. It's all automated, tends to use machine learning, and there is some kind of database. So obviously you save the decisions that you've made for the next time you might see that variant. And I think they all have really good API functionality, so it can fit in with your LIMS or your different systems you're using. And really importantly, and what we want, particularly in clinical diagnostic use, is to have a short list of variants that it has recommended that all have a high likelihood of being causative. So we are utilising our quite precious time in the NHS to look at those important variants rather than spending a lot of time classifying benign or likely benign variants. And they all have some way that you can do the analysis and a customized report within the platform, and then kind of attach that to LIMS. So that was it for kind of an overview. So I'm going to start with part 1, which is all to do with this validation and implementation of one DSS in Sheffield. So the DSS that we have validated is called Emedgene. It's an AI-based platform that incorporates machine learning throughout the analysis and interpretation workflow to deliver the fastest time from genomic data to decisions. And one of its features is it says it's got this kind of explainable AI. So for any variant it's prioritized, you can see this kind of flow chart. Yes, we've got this flow chart here that explains why it's prioritised it. The ones that are being filtered out are hopefully based on your kind of filtering you've already approved. But I think what's much more of a burning question, and what I get asked a lot, is how do you actually pronounce it? Because a lot of people say Emedgene. Well, I have it from very good authority, which is Claire Logan from Illumina. So hopefully Claire is on the call. But that the founders of the company do talk about this and say it as Emedgene. So think about kind of John Lennon, and if you try and say it very quickly, like Imogene turns into Emedgene. So now we've got that cleared up, I will move on to the workflow, and just very simply, you are basically getting your data from whatever source that's coming in. You're putting it through the pipeline to call the variants. Then this is kind of really where the power comes in. You're using this explainable AI and automated workflows to get that short list of variants. And then you've got the database. And for Emedgene, that their database is called Curate. And then you're going to generate, after you've made all decisions about that variant, a customized report. But before we can get to that stage is a really, really important step, and that is information governance, and in particular, making sure you have a DPIA in place, which is a data protection impact assessment. And, it's really important to us in the NHS indeed in other places as well, but in the NHS it's very, very strict. We have to look after patients' data, and in particular genomic data is really can be very sensitive data, and so it's really important that we have measures in place to ensure that it's protected. And so the DPIA goes through kind of a risk assessment process and make sure you have measures in place to mitigate any risks of kind of data breaches. So this is an example diagram from our GLH's DPIA showing that the data is pseudonymized, and then when it goes into the Illumina cloud services, it's kind of also deleted, and we have measures like that, and that it's kind of all in a very secure cloud environment. Now, this step can be a massive hurdle in some places. I wasn't actually involved in this DPIA, but I've been involved in several throughout my career, and some of them have been very, very slow. So it's very much the interaction between the company and your trust, or in our case in North East Yorkshire, can be multiple trusts, to make sure that process works efficiently. So in our experience, this went very smoothly with Illumina doing this. I think one of the reasons is that we have very strong leadership in this area, and we have a GMS information governance working group that includes the data protection officer from all 4 trusts in our region, and so we have worked very hard over the last 4 to 5 years to ensure that this process works smoothly. However, there's other people in the Emedgene NHS users group, I'm going to talk a little bit about that later, that I know are finding this a massive hurdle, and basically they are stuck and waiting for this to progress before they can really start validation. So I thought this was worth mentioning at this point. So once that is all sorted, then we can kind of get on and start the validation. And just to focus on some of the initial wins that we had, it uses the Dragon pipeline, which is a full bioinformatic end-to-end pipeline, does all kind of different variant types, really, really efficient and very, very highly accurate and good quality pipeline. You get really good data-rich annotation, which I'll show in a minute, allows you to do very, very good, fast, proportionate variant analysis. You have the explainable AI, so you can see why it's made that decision, and it kind of attempts some form of ACMG variant classification. It's also very customizable and interoperable. So you've got the flexibility to tailor settings to whatever cases that you are putting in. You've got that API connectivity with different systems, and obviously the workflows can all be automated, which saves time. So looking at the first 86 cases that we put through, so I should say that when we first started this project, it was actually a whole exome project, but we then kind of moved into doing NGS targeted data, and we shelved the exome project. So for the remainder of this part of the talk, I'm focusing on NGS targeted data. So just from that initial 86 cases, just from the settings kind of straight out of the box from Illumina, we saw a 44% reduction in the number of variants returned, so 364 to 204. And we had 19% of cases with no variants returned. To show you kind of the data-rich annotation, so this is usually all in one line in Emedgene, but I've had to kind of split that on the right-hand side down into kind of 2 lines. So it looks very busy, but it's just to show how much annotation you get for each variant. Hopefully you can see it also ranks the different variants in terms of the priority. So the number 1 variant, and it will separate them out into most likely and candidates. And it means you can really quickly just scroll along and you can look at all the data from that variant, and you can decide either this variant is kind of the full explanation of all of my patients' clinical symptoms, I don't need to look any further, or you can very quickly exclude different variants if they don't fit the right inheritance pattern, or they don't fit the phenotype, etc. So for anyone not kind of aware of how we do variant proportionate analysis in the NHS, Ian Berry's done a very good talk here that's available on YouTube. And for any clinical scientists that are using proportionate variant analysis, there's also a pilot Genie module EQA scheme that's open at the moment. So you should have a look at those. But like anything, your initial things are very good when you first open something, but when you do a bit of a deeper dive, you find some kind of little glitches. And so these are some of the cons that we identified. The most important being is that we missed multiple causative variants. In addition, because of the kind of like, although it's very flexible, you can create lots of different settings. At the moment, the logic for those settings is limited and you can't do the if or logic. Therefore, you need to create new presets for different scenarios. So that means you do have more presets to check. They are very quick, but it's still extra clicks. This is going to be improved in kind of later versions, but yeah, this is where we're at now. Another kind of bit of a minus for us was that it really, for NGS targeted analysis, does not work very well for genes that are affected by segmental duplication. In our own kind of in-house pipeline, we mask the pseudogenes in the reference genome, so it means that any calls are forced to kind of to be aligned to the gene of interest. However, we can't do this within Dragon and Emedgene, kind of how we've got it set up. So we've had to kind of exclude those panels. We also found that it needed a lot of updating. So there were multiple updates, both to user interface and to the bioinformatics pipeline that we had to do during validation. And each of those kind of required additional work. We also found that we didn't really like the variant classification module, and the kind of buttons on and off were a bit clunky. The strengths weren't quite right. It's using ACNG guidelines rather than our ACGS guidelines. So we've chosen to use our own variant classification database instead. So obviously the most worrying of these is the missed variants. So a lot for CMVs, and we'll come back to them in a minute. Regions of segmental duplication I've just talked about. We also had a couple of multinucleotide variants. In particular, we've got one pathogenic one in the SBDS gene that we still haven't managed to rescue as yet. There were also common variants missed. So, for example, the sickle cell variant, we had to create a new preset for these known pathogenic ones, and risk alleles that we do report in a number of circumstances like hemochromatosis or Gilbert syndrome. So again, we had to develop our own preset for this. We also had some large indels between about 35 and 50 base pairs that were missed, and a structural variant, which, to be fair, was maybe a little bit difficult. So this one was picked up by diagnostic discovery. There is a structural variant caller within Emedgene called Manta, but it's too noisy for NGS data. I think if we looked at this with whole exome or genome data, it may well be different, but yeah, we can't kind of get that structural variant from the NGS data. Importantly, the vast majority of these have now been rescued with changes to the setting or pipeline upgrades, but each of them did take quite a lot of work. Really busy slide. I'm not going to go through all of this text in terms of the core validation work, just to say we did a lot of work. Probably the ones to highlight are the top 3, to say that we did that kind of original just panel, which was side by side other cases. But then we started to throw at it once we had a bit more confidence, more edge cases. And by that, I mean variants that are a bit harder to detect, to make sure that we're really kind of, testing its kind of limitations. We also have big delays because of issues with the bed file. So the bed file that we use our in-house pipeline, which we just got from our Sure Select design, we use Agilent Sure Select, was just not suitable for use within Emedgene. And so that has caused quite a lot of delays from our end, having to kind of remake those bed files. And quite importantly, we also found causative variants in both the most likely and the candidate presets. So we combined them into one. This works for NGS, it won't work for WGS, so we're going to need some kind of different changes in settings. And then the other thing to highlight is there were quite a few things that if we made a change, we couldn't make the change ourselves. It had to go back to Emedgene HQ. I would say at the beginning that this was quite a quick process to become very responsive. I think a lot more labs are kind of bringing Emedgene online, and so it has got a bit slower, and there were a couple of instances where we were waiting about 3 weeks. But I'm really pleased to say that now with the new version of Emedgene out, there are more options for self-serve. So some of this we can do ourselves without having to send it to HQ now. So yes, the path to validation was a bit wiggly up and down. We kind of would hit a roadblock and we'd have to kind of do additional work. So it took us in total about 10 months. As I said, that is kind of, starting off with exome, changing to NGS. I also would say that we know that we'd already seen presentations from the Northwest GLH who've done a huge amount of work in Emedgene. And so seeing kind of those presentations and also speaking to kind of key people in Manchester that we knew that they liked the system and it kind of had found fixes around most of these issues as well. So that kind of gave us quite a lot of confidence in it as well. So just to quickly show you our presets, again, I'm not going to go through this, but just to say that there's like 4 kind of what we call our compulsory presets, but you actually have to check 3 different presets, 1, 2, and 4 for CMVs, just because of that lack of the if or logic. And then we have these 3 additional optional presets that we would use for specific cases or specific services. So onto the CMVs and particularly the NIST data, and this really demonstrates the power of data sharing, and a big thank you to the Northwest for sharing their CMV data with us. So because we found that the majority of the CMVs variants that were missed were CMVs, we decided in North East Yorkshire to go live with using another CMV crawler called Decon that we use a lot in parallel to Emedgene. This kind of worked really very well. The results all look very comparable, but we weren't really doing many confirms of positives from that data because they were mainly single hits in recessive genes. So we had, I think, around 40 CMVs and positive CMVs, and our kind of bioinformatician that's been leading on all of this, Ali Jones, who's also kind of on the call today, worked out that I think we needed about 65-ish CMVs in order to get that 95% confidence interval. But thanks to the data sharing with the Northwest, we've now combined our data sets together and we have a total of 87 CMVs. So out of that 87, 14 CMVs were missed. 4 were single exon heterozygotes. I would note that we have a lot more single exon heterozygotes that were picked up, and all of our single exon homozygotes have been picked up. 2 are mosaic, and 8 are in genes affected by segmental duplication. The ones with segmental duplication, we know that these are really difficult to detect, even on our kind of in-house pipeline with all sorts of different work we've done on them. So we would normally do that by MLPA, and we know that the mosaics have lower sensitivity. So it seems reasonable to exclude those. And excluding those, then that gives us a 95.4% sensitivity. But I would say these are not representative of the variants that you would find if you were kind of just going through genomic medicine routine cases. We have purposely picked edge cases and more difficult ones. We had a lot of single exon deletions in there. I'm hoping that sensitivity will be a minimum of 95%. So another piece of work that Ali has done, and thanks to Ali for this slide as well, is to do an automated negative case checker. So this is kind of what happens to the data in our local GLH. It then kind of transfers to the Emedgene AWS bucket, where the case is created and run. And once it's kind of gone through their pipeline, then it's set to delivered. And at this point, we use a function within AWS called the Lambda, and that then triggers this negative case checker. And all it does is look at the presets and counts how many variants there are. If there are any variants in those presets, then it does not change the case status. However, if there are no variants, it will change the case status to negative. So what this looks like for a real case, as you can see for this top one, it's been set to negative. So we know that there are no variants in this one, whereas this one that says delivered, we know that there's at least one variant. And this means for our checking process, if it has been already tagged as negative by the software, then we don't need to do a first check, and just the GT can go ahead and generate a normal report for that patient. So once all the validation work has been done, the next step is implementation. And also do not underestimate the amount of time this takes, because you need all your validation paperwork, your SOP, all written, approved, and in your quality management system. You need to think about your training plan, your competence documents, and ensure you have enough staff trained and competent, ready for go live. Also, you need to think about UCAS requirements and submitting an extension to scope. So in summary of the results, based on all the changes we made, including adding some more filters into the AI returned variants, we actually got between a 60 to 63% reduction in the number of variants compared to our in-house pipeline. And then for the variants that are remaining, we saw much faster proportionate analysis of those. I'd say Illumina have been really responsive to our requests, but there were some delays with sending back to the Emedgene HQ. I would say it's been a really useful process both ways. I think hopefully, well, Claire certainly said that to us, that they learned a lot from kind of going through this process with the Northwest and with us. So we went live in Sheffield in October 2024. We've kind of done nearly 250 cases in it because we've limited it to 2 services at the moment. But we've seen a really positive impact on reducing backlogs and improving turnaround times within those services. So I think the big negative at the moment is that we cannot use it for panels with affected by segmental duplication. So we're having to kind of keep panels on our in-house pipeline, but we are hoping with upgrades that are coming to Emedgene that will improve. So the next steps are currently working on upgrading it to build 38. There's a new version of Emedgene, version 37, which has got a lot of changes in. I think this is only just a few, but the really key ones are it's got a new version of Dragon, version 4.3. So we're really hoping that will improve the CMV calling. It's got all completely new features for visualization of CMVs. Should be some improvement segmental duplication, but we've not started testing that. More self-serve features. So we're about to start validating this and then kind of looking to onboard new services. So in summary, kind of the lessons learned is that I would recommend that you get your data protection officer's engagement in preparation for your DPIA process. I think it's really fair to say that the product's straight from the box, and we are talking kind of end of 2023. So we have been through quite a few upgrades since then, but at that point it was not really ready for clinical use. We have had to do a lot of work kind of in-house, and we know they've done the same in the Northwest. Validation and implementation take time. I hope you've got that from this this kind of brief talk. And then every time there's a new version, we have to kind of revalidate. And there's lots of ongoing work that we want to do, but that more self-serve will help. So just to say massive thank yous kind of to the Sheffield team, in particular Ali, Rodney, Sam from our bioinformatics team, and then Lauren Mansfield, Lauren Turton, Catherine Benton, who were really instrumental in doing some of the implementation work. And then in Manchester, I know that the whole project was kind of led by Andrew Wallace. Liz Sollers, as a bioinformatician, has been very, very helpful for our bioinformatics team. And Chris Campbell has been the scientist involved there. I've got a couple more slides, Alex, that's okay. So I just wanted to kind of mention our Emedgene NHS user group that I set up. Again, don't need to kind of go through all of this, but we've kind of got people involved from kind of all over the UK. It's just the Northwest and Northeast Yorkshire that have it validated, but there are quite a few others that are validating it. And our kind of main aims are to share our experiences and support the validation process. And what I'd really like to do is have these kind of approved NHS presets for different scenarios that we know have been kind of really well tested, and have our own NHS version of Curate database that we can do that data sharing of variants. And you can see how other labs have classified different variants. And that's open to kind of all other Emedgene NHS users. Again, we're limiting it to NHS users. That was the agenda from our last meeting. So we're kind of looking at various different things. And then I just wanted to talk quite briefly. It's more of an introduction really to kind of part 2, was all about the work that I am doing as part of the Rare and Inherited Disease Genomic Network of Excellence. So yeah, different network of excellence, the AI one, and this I'm looking at DSS evaluation for exome and genome data. Quite a busy slide, but this is just like an overview of the what the Rare and Inherited Disease Network of Excellence does. So the main kind of aims are to develop recommendations for optimal care, improve diagnostic and clinical pathways, share practice and policy, and provide support and education. Got a huge number of stakeholders involved and lots of kind of patient group involvement. And then all the work is divided up into these 4 different work packages. And the work that I'm doing for the DSS falls under work package 3. So it's increasing the efficiency of analysis and reanalysis using data-driven approaches. So just to kind of give you a bit of an overview of the project plan, the first step was to define the requirements, what we wanted from a DSS, kind of, and this was a lot based on my experience of already implementing and validating Emedgene. So it's coming up with a list of must-have and nice-to-have features. Then identifying different DSS that would be suitable and kind of making contact with all those companies. So I've got 10 kind of at the moment that I'm kind of working with. Then the next was kind of all the onboarding meetings and having demos of the software. And this took between 2 and 4 meetings just to kind of get set up and have demos. And then the next stage was to kind of get me access and to some kind of trial or sandbox version of the software where I could have a play with the different features. And the plan was at this point to try and evaluate all of those things that were on the must-have and nice-to-have list. But I kind of quickly found that they needed lots of bespoke settings, and because the demo cases that were loaded in were all different for the different softwares, it was really hard to compare like to like. And so it was really hard to give them a kind of score and a weighting apart from just to say yes or no. So I knew that I wanted to put some cases in, but then we hit that kind of hurdle of the information governance. And the idea of trying to get a DPIA for 10 or more companies was kind of, slightly concerning, and I quickly realised that we couldn't do that. So instead, very lucky, and thanks very much to kind of Emma Vapel and Joe Leslie, who have access to research samples that have been consented. So there was then other kind of hoops for me to jump through in terms of getting honorary contracts and a laptop, etc., so I could get to that data. But we've now got some consented research samples with a mix of different interesting variants, mixture of singletons, trios, exome genome data, fast-cube DCF, etc. And we're now at this process of trying to get that data uploaded and ensuring all the data security and everything is fine, and that no one gets to keep that data, etc. And then once that's done, the next steps will be to evaluate by features, usability, and by the 6 cases. And then the final plan will be to write up this work as a report. So the aim will be to present findings. There will be no recommendations made because we're very aware that for different laboratories, they have different use kind of requirements. And so it's going to depend on how they want to use it. So yeah, just final slide now is just to acknowledge Emma, Joe, Lucy and Andy from the Exeter lab, Joe Halstead from the Cardiff lab, who kind of supplied the BCF for me as well, and all of these companies who've been very accommodating and are taking part in that. So thanks. Up for any questions.
Thank you so much, Miranda. If our audience could join me in a virtual round of applause for that brilliant presentation, and it's great to hear things from the frontier as it's being discovered, as it were. I'm going to be a bit selfish and start off with one question from me, if that's all right. Because when we were establishing the Genomic AI Network, one of the first pieces of work that we did, hello everyone who's come to the call a little later, by the way, I'm Alex Stang, a clinical geneticist and a clinical lead for the Genomic AI Network. The survey that we did for genomic medicine services, the top barrier identified for adoption of these tools was workforce and education. From your experience, what was the size and scope of the type of workforce transformation that you had to do in order to support the actual pathway transformation? Was there enough of the expertise existing in your GLH of the right skill sets, the right roles, at the right seniority, or did you have to take action to remix people into the right roles and skill set and upskilling to get this up and running?
So I can only speak kind of from my experience in the Northeast Yorkshire, but no, I would say in general we do need a lot more kind of training, education on these tools. I think luckily the majority of them make them fairly easy to use, and that is one of the things on my kind of must-have list, is that kind of, you don't want something that looks very complicated, you want it's nice and easy to use. So really for the validation of Emedgene, then it was mainly one bioinformatician and one kind of site, which started off as one person, so that was Rodney, who's kind of does was half-time bioinformaticians, half-time clinical scientist, and then kind of moved more to include Ali and me in that validation. So it was a very small kind of group of us because of just the resources that kind of were required elsewhere.
Thank you. For everyone else, we're on the Q&A tab now, so please get asking and voting. I'm going to pick the highest voted question, which is Tom Dyer, says, what was the benchmark for existing number of variants or cases returned compared to Illumina system, i.e. Emedgene versus your, I guess, baseline workflow comparing against?
Good question. I don't know how many cases we've put through in total. We've got about 4 validation forms because we had that initial case, then we had another panel of edge cases. Then every time we missed a variant, so for example the common variants, then we had another kind of panel of founders. I searched cases that had founder variants to make sure we weren't missing other kind of known pathogenics, and to test out that preset. And then we had another test for the risk alleles. So there were kind of multiple different panels of kind of patients put through. I can't remember the total number of variants that we have ended up looking at, but it will be, we're into the kind of, it's certainly between probably 100 and 200 patients. So yeah, many more variants. I'll be able to probably find that out, but
and the number, was that just a function of the subsets of the function of the tool that you needed to arrive at, or is there an existing gold standard anywhere that says this number, you are safe after this number of validations, or have you sort of ballparked that?
Yeah, there is that in the bioinformatics. So we made sure that we could get the 95% confidence. And I'm just sorry, I don't know the numbers off the top of my head, but yeah, we were kind of easily in excess of the numbers required. Where we fell down was the CMVs, and as I would explain that we then got those kind of numbers up by the data sharing.
You mentioned also that you'd need to revalidate for every new version that came out. Would you have to revalidate on every subset, or is that a general? How do you do the case mix for that?
Yeah, again, so it's looking at some of the cases that you had went through before that you did identify the variants, and some of the ones that where it wasn't, to see if there was any improvement. So it's a kind of a little bit of a mixture of both. So we didn't necessarily validate every single case. We picked out kind of some of the more interesting cases, and then obviously for each case they've got multiple variants, so that kind of could help tick those off.
A bit more of a bespoke or curated process on the revalidation.
Yes.
Yeah. Brilliant. I have a next question, which is upvoted from Nicholas Pantikos, who says, what about the false positives? Is this ranking or filtering only the causative variants? And you mentioned that the false negatives were a big cause for concern for missed causative variants. Did you go looking for the false positives, or was that apparent to you on the output of the algorithm?
So when you say false positives, there are kind of, in a lot of cases, we end up reporting as no genetic cause identified. The software does return a number of variants. And so we, we'd still look at those and kind of exclude. So it doesn't mean anything that's returned is then reported. You would still, look at those and say exclude on phenotype, exclude on, right. So because we are using these as NGS targeted panels, we're not adding in the HPO terms at the moment, and we obviously don't have that phenotype information. So if you've got trios plus the phenotype, then you're hoping that the filtering is better. Obviously, then those tend to be whole genome cases, which we've already had a kind of a look at some genome data, and it's returning a small number of most likely, maybe up to 10, but sometimes only kind of like 3 to 5. But it's returning up to 100 candidates as the kind of the default settings are currently for WGS. So I'm started having a look at that with the Exeter lab. We've had some conversations with Sick Kids in Toronto, and hopefully soon to be having some conversations with Erasmus in the Netherlands to see how we can improve that filtering. So it kind of depends on the context you're using it in.
I have a next question from Gavin Ryan, who says, are you working with Genomics England on implementing AI and interpretation browser, which was, I believe, part of what they presented at the last one of these meetings? Uh, I guess that's a broader conversation about what's the cross-institutional talk or pollination or coordination on these types of efforts.
Yeah, so I am in kind of regular communication with Genomics England. So they have already evaluated one of the DSS on my list on 200 variants, and they're nearly there on doing a second one. So going to share that data with me, and I've asked whether there's any option of kind of looking at another group of them. Again, we've just hit the ID issue and where that data sits. So we're kind of trying to work through that. But yeah, in an ideal world, because probably what I didn't make clear enough is this DSS evaluation is not a validation. I think I've hopefully made it clear enough that the initial bit of it, the validation takes time. I do not have that amount of time. I work for the Network of Excellence 1 day a week, so I don't have time to do a full validation. But if we had that kind of sensitivity, was kind of precision and recall data from looking at 200 positive cases like Dell do, then that would really feed into it nicely. So we're trying to work through it. I don't know if that's kind of going to help with this report.
Mm. And on that theme of sort of cross-institutional collaboration and ownership, you mentioned earlier about approved presets for these types of things for, I guess set it once so that not everyone has to reinvent the wheel on these other things. Do you have an instinct on who should own that, who should curate that, where it should live in the NHS?
Well, my thoughts and feelings are always that we should just be collaborating between labs because we work for the NHS and for that benefit. So therefore, that was kind of one of the reasons for setting up this NHS, Emedgene user group meeting. So I've shared with everyone on that group the settings that we've come up with. I'm not saying that they're, necessarily the best. They're the best that we've come up with, so far. And again, it's the context, so they work for that kind of NGS targeted context. I don't know about kind of where the ownership of that sits. I think obviously trying to keep it within the NHS, but yeah, we've also had those discussions with Sick Kids, and we've done some. We've wanted to set up NGS, and we wanted to set up WGS, so we've done some cross collaboration there.
Thank you. Liz Edwards asks, how many samples do you have now for the cross DSS analysis, the second project?
Yeah, so I've ended up with 6. So I've got one VCF that's like super mutated. That's from Joe in Cardiff. So it's got lots and lots of variants in. Then the rest are all kind of FASTQs and are kind of a mixture of exome genomes and trios and singletons. And yeah, we've chosen ones that got kind of interesting-ish variants, but I don't think I could probably do any more than 6 cases kind of per software, because that's just going to take quite a bit of time. But yeah, it isn't enough to properly validate it. I'm just going to have to kind of say, as I said, functionality and usability.
Thanks. The next one with highest votes is Chris Mattox. Chris asks, I note Emedgene is a RUO tool. I assume that means research use only. And you've clearly done extensive validation. Have you looked into, and do you have any comments on the implications of the new medical device legislation on the use of these tools for
Not my area of expertise, thanks, Chris. But I would say that the ones that I'm looking at in terms of that 10, there are a couple that have kind of a CE-IVD mark, but previously that kind of hasn't made that much difference in a diagnostic lab, because we still have to do that validation regardless of whether it has this kind of that CE mark or not. And as the majority are not yet kind of regulated, then that didn't really kind of swing our opinion in terms of which ones we should be looking at. But yes, as that new regulation comes in, then it will become increasingly important that they have that regulation in place.
And a comment from our side that NHS Shared Business Services put out a call for all sorts of AI tools, including AI and genomics. So it'll be interesting to see what sort of framework they come up with in trying to set the tone for procurement and standards in that space for lab owners. I see the next one that's got votes is Eleanor Williams. Is the Curate database pulling data from ClinVar, or is it Illumina in-house data? And how often is it updated?
I can't answer the question in terms of how often it's updated. I think it's regularly, but I don't know. But yeah, so the data is, and the variants are annotated, including the ClinVar status, and then you choose to kind of add your variant to Curate once you've decided on a classification for that variant, and then that is the kind of the classification that is then kind of saved and can be shared with other users. So if you're just excluding it because it's not relevant in that patient, you wouldn't kind of add it to Curate. It's only if you kind of, you're saying either I'm classifying this as benign because we've already previously classified it as benign. So we're trying to reduce down the number of times we are spending time classifying variants as benign and likely benign, because we want to focus on the more causative variants. But if we already have that from our variant database classic, then we will kind of annotate that and add to Curate. And then obviously the pathogenic ones, anything reportable, we will annotate and we will kind of add the evidence in, and then they're the ones that can be shown. But yeah, it does show the ClinVar status and it shows the HGMD status as well when you kind of scroll along, so you can see that for each variant.
And for the purposes of future audiences on our channel, Ali Jones has replied as well very kindly. The Curate database is populated with our data and variant classifications and is used as an additional input into Emedgene's scoring weighting of variants, although Emedgene does use ClinVar in its annotations and decision making. Thanks very much, Ali, there. Here's a very interesting one on vendor lock-in, Miranda, which is from Liz Edwards. How easy is it to pull out your interpretations from the integrated Curate database if, for example, in future you decided to change vendor?
I have no idea. I'm sorry. Not fast. I mean, it's a database. So yeah, Ali, do you know?
Well, we'll come back to it and see if any replies materialize. Yes.
Claire's on the call.
Ali does say, I think this is a feature. However, we've not tried it extensively. Our workflow uses another database called Classic, where these are imported from an automated process, so we can actually have a local copy. Anyway, it sounds like it's very dependent on local informatics logistics in that case. Maybe last few then. Nick Hickson asks, are there any plans to develop or review, I assume as part of your DSS review, existing general AI/large language model tools for variant interpretation? Is that in scope, or is that another project altogether for you?
It would be lovely to do that, because obviously particularly the potential of search and literature and things for that. But that was kind of the subject of last month's talk, wasn't it, for the Genomic AI Network? But no, it's not in scope for this. Looking at the DSS, some do include it. So, for example, there's VarChat from VarSeek, and so that's kind of freely accessed. I use that quite a lot now, actually. So yeah, some of them kind of have that feature within it, but most of them are, it would be a separate project. But that's definitely something Genomics England have been doing as well. So worth catching up with that recording. Didn't catch it.
If anyone out there in the wild is particularly interested on that theme, do contact us and we'll talk further about it. Maybe time for one last one then, Miranda, if you're happy.
Try.
How did you pick which tools to evaluate in your head-to-head project?
Yeah, that's kind of been a little difficult. Some of them are already new, and then others I just found from kind of Googling or looking at through publications. But then I've had a couple that have said, "Oh, you've missed us out," or so. It's kind of organically grown. There have been a few that I've looked at and thought this doesn't really fit quite the remit. Like they'd post different more different bioinformatics pipelines in certain areas. So there have been a few that I excluded, but really I need software that's all quite similar in terms of what it does, and it's to make the job of the clinical scientist easier, really, and for us to focus on those variants that are most likely causative. If I have missed anyone, please let me know.
I think that's everyone that I could see. Thank you, everyone, so much for your questions. I'm just popping something in chat of if you're not signed up to the Turing Clinical AI interest group with the Genomic AI subgroup, here's the link to do so you don't miss any of our future sessions. And Tasnim is just about to bring up our, if you weren't here at the beginning, joining link for the in-person workshop in Manchester in June for practical workshops on AI from both the clinical and the laboratory side. So this will include variant interpretation pipelines in the laboratory, biocuration AI from Genomics England, facial dysmorphology AI tools as used in interpreting ACMG criteria on the clinical side, as well as ambient scribe, so large language model clinical note summarization. On the clinical side, there'll be parallel paths for the clinical and laboratory sides of this, as well as a regulatory and panel talk in the morning. We hope to see many of you there, and this is free to join for NHS employees of the highly specialized genomic workforce. It's been brilliant to have you, Miranda, to have your unique window. I don't think anyone has as much of a finger on the pulse of what's happening with all the variant interpretation and decision support tools. So it's brilliant to have you share your wisdom and answer so many of our nitpicking questions, I'm sure, on it. Best of luck with the progress on the decision support head-to-head report. We really look forward to reading it. And for everyone in the audience, thanks for coming, and we hope to see you at a future edition of this program.
Thank you.